Hi, very good morning to all of you. The NSEJS exam has been already over. So I hope you have wrote the exam very well. And the for today's class, we will be having a discussion of the physics questions. So we totally have in the question paper, we have the questions from 17 to 32. So we totally have a question of 16 questions for physics. And so we'll be discussing each questions one by one and also the detailed solution. Okay, so starting off with the first question. Uh, the question paper code might vary actually. So I haven't actually numbered it from 17. Instead, I have numbered it from 1 to 16. Okay, so starting from the first question. The first question that I'm discussing is a student intending to catch a bus on the bus stand. Find the bus, find the bus starts and accelerate away from him or her with uniform acceleration equal to 2 meter per second square. When he is 16 meter from the bus, he runs fast enough with a uniform speed so as to just to catch the bus. The minimum speed with which the student must run. So if you look into this solution, first of all, we will be discussing or we will be pointing out the data that is given to us. So in this particular question, we know that the data that is given. So the bus is actually starting. Starting means initial velocity. We will be considering it as zero. Okay. So starting and accelerates away from the person with a uniform acceleration of a equal to 2 meter per second square. Okay. So this is the uniform acceleration that is provided. He was 16 meter. He is already at a distance of 16 meter. The bus is ahead 16 meter ahead from the student, and then he has to run with a uniform speed, like he has to run with a constant speed of u, so that he can actually catch the bus. So we are also given that distance or the bus is ahead by a distance of 16 meters. So this is a case of equations of motion we can actually use. So imagine that student is running with a velocity, like let us say a constant velocity of u is the constant velocity by which the student is going to run. Okay, so like the position of the bus, let us say it is denoted by x. Okay, the position of the bus after a time t will be equal to s equal to ut plus half a t square, where we know that initial velocity of the student is zero. So let us say that like let it be xb, position of the bus after a time t will be equal to half a t square. So here acceleration is given as 2, so that will be become half 2 into t square. So the position of the bus after a time t with related to time is t square. So this is our equation, and the position of the student after time t. So if he is actually moving with the velocity, uniform velocity, we are talking about uniform velocity. So if the student is moving with a uniform velocity u for a time t, then the position of the student xs will be, let us denote it by xs, will be equal to u into t, because we know that velocity is distance or position with respect to time. So from this, we know that it is u into t, and the student is, he runs too fast with a uniform speed, so he is not accelerating. There is no acceleration component. Okay, so the student can catch the bus when this position. Actually, we will be equating these two equations, but there is a catch because the bus is 16 meter ahead of him, which means that the student will be able to catch the bus when his position ut will be equal to the position of the bus plus 16. Okay, so this is the equation that we have to solve. So I'm naming it as 1. So what you are getting, so as we said, the student will be able to catch the bus when the position of the student ut will be equal to the position of the bus, and the position of the bus is actually 16 meter out, so we have to add 16 meters. So you are actually getting a quadratic equation, which is t square plus 16, t square plus 16 minus ut equal to 0. So you're actually getting a quadratic equation, and you have to calculate the values of this quadratic equation. For that, we should be considering only real roots. Okay, so for real roots, we know the condition for real roots. The discriminant should be equal to 0. Discriminant root of b square minus 4ac should be equal to 0. Discriminant should be equal to 0. So the discriminant here, while on solving the discriminant, you are going to get it as u square minus 64, 4 into a into c. Okay, because c is 16, 4 times 16, 64. This should be equal to 0. So what is u square? We are actually looking into the real root. So the minimum value of speed u must be equal to root of 64 which is equal to 8 meters per second. So this is the answer. Like the answer is C, which is 8 meter per second. So C will be the right answer. Okay, so that is the minimum speed by which the student has to run. Okay, so now moving on to the next question. A block of mass 2 kg is suspended from the ceiling by a massless string. The string is taut, bearing a definite tension when the block is stationary. Suddenly, the string breaks and the block starts falling freely. The difference in the tension in string just before and after it break is okay. So here we are actually considering. We should be considering the forces that is acting on the string. So we have the data that is given is we have the mass which is m is 2 kilogram. 2 kilogram is suspended in the string. So before breaking, like the string is taut means string is actually fixed and it hasn't break. So before breaking, the block remains stationary. So the tension, like when it is like this. Okay, so before breaking the string, there will be a weight acting which is vertically downwards, which is mg. And in order to hold this weight, the string will be having tension. So the tension will be equal to the weight. So let us call this tension before breaking as T1. So T1 is nothing but equal to the weight of the block. Okay, mg. So uh, we have to consider 9.8. Okay, G is taken as 9 because from the option you can see. So 2 into 9.8. So the initial tension in the string will be 19.6 Newton. Okay. So this is the initial string. After breaking, they have said that suddenly break and block starts falling freely. So during free fall, we know that acceleration at which the mass is falling will be equal to the acceleration due to gravity. So hence, there won't be any effect on the string. So there will be no tension. So the tension in the string after breaking T2 will be equal to 0 because it is under free fall and there will be no effect of weight. So the difference in tension will be equal to just before and after it breaks will be T1 minus T2, which is going to be 19.6 minus 0, which is 19.6 Newton. So the answer for the question is option B, 19.6 Newton. Okay. So this is actually a very simple question. It's basically how you determine the value of forces and how you determine the free body diagram and then represent the question. Okay, so now moving on to the next question. This is a theoretical, like this is a question that we can actually analyze theoretically. So having been paddled continuously on a horizontal road, the speed of a bicycle is increasing. The force of friction exerted by the ground on the wheel is, see, bicycle is accelerating. So speed of the bicycle, like there is a bicycle. So let us say there is like bicycle. Excuse my drawing. Okay, so there is a bicycle which is moving on a horizontal road. The speed is increasing means the bicycle is actually accelerating. Okay, so when is a body accelerating? If the body is accelerating, it means that we know that Newton's law of motion or in force, we have studied about force, right? So whenever we apply a force onto an object, there will be an acceleration happening to the body, right? So the speed is going to change. That is one effect by which force can create. So net force is actually acting forward. So that is why the body is accelerating in the forward direction. So ground friction on the wheel provides the driving force. Okay, so here the force of friction exerted by the ground on the wheel is what we are, the direction is what we have to find. Okay, so in the rear wheel, we know that in a bicycle, the rear wheel, the backside wheel is the wheel which is the driving wheel. Like, because that is where the chain is being connected. Okay, so friction in the rear wheel, the friction is acting forward, which actually provides the external push so that it is actually moving forward with the acceleration. And on the front wheel, uh, the friction acts backward. Okay, because it is not the driving wheel. Front wheel is actually, uh, it's free to rotate kind of thing. So the friction is acting in the backward direction. Okay, so uh, so in order to move forward with the acceleration, in the back wheel, the friction has to provide the forward force, and in the front wheel, the friction will be acting in the opposite direction or in the backward direction. Okay. So if the net effect, if you calculate the net effect of friction on both the wheels, and if the forward force is more, it will be accelerating. Okay. So the correct option will be in the backward direction on the front wheel and in the forward direction on the rear wheel. So option D will be the correct answer for this particular question. Okay. Okay, so option D is the correct answer for this particular question. Now moving on to the next question. A current I equal to 2 ampere. Okay, so 2 ampere is established through the long straight conductors, which are the arms of a hairpin-like structure placed in the plane of a paper as shown in the figure. So there is a figure actually. So the figure kind of approximately looks like this. Like I'll just showcase a figure. Okay, so this is the figure. Like we have a hairpin, we have a pin which is actually having a hairpin. Like hairpin, you know what a hairpin is, right? So this is the figure that we are having. So in this, 2 ampere of current is passing through the long straight conductors and the which are the arms of a hairpin-like structure placed in the plane of a paper. Knowing that a current carrying conductor produces a magnetic field represented by the line of force, analyze the situation described and the correct option. So we are actually having different different numbers or different points marked in the different points marked in the hairpin. So I'll be marking the points here. So the points in the question, like so this is the so moving on to like I will draw the exact figure. Okay, so there is there's a hairpin like structure, and here like we are having a battery and a switch is there, and then we are having one rheostat. Okay, resistance is there. Okay, so this is the structure. So this is positive and negative. We are applying a voltage, so that current is passing. Okay, so the current is passing in this direction. Let us say in the anti-clockwise direction when we are looking from the above. Okay, so there are similar different points. So this is point Q. This point is Z. This point is P. This point is M. We have 5 different points marked in this particular question. Okay, this point is N. Okay, so now out of the following option, we have to find out which option is the correct option or which option represents the correct direction of magnetic field. Okay, so we know that whenever we are applying a current onto a conductor, it obviously produces a magnetic field. Uh, Moving current actually creates a magnetic field. So the direction of magnetic field, we know how to find the direction of magnetic field in a straight conductor, right? So if in a straight conductor, if the magnetic field, if the current is in the upward direction, we will actually be using right hand thumb rule. So what does right hand thumb rule states? So the right hand thumb rule states that if we are pointing the thumb in the direction of current, the fingers, remaining fingers will actually, if this is the conductor, if I am pointing the thumb in the direction of current, the fingers curling will be the direction of magnetic field around the conductor. So for a straight conductor, we know that the shape of the magnetic field will be concentric circle. So using right hand thumb rule, if you analyze each point, we can actually see like we have to place the thumb in the direction of conductor. Okay, so the direction of current is from in this sense it is from left to right. Okay, sorry, right to left. So if you are placing the current, so we can know that the magnetic field will actually be going inside above and it will be coming out when I am placing the thumb here in this particular upper section. Okay, so at P, the field is into the page. Analyzing each, we can actually understand that at P, the field will be into the plane of the paper. It is going into the plane of the paper. And at Q, it will be out of the page. Okay. And at Z, if you look, it is tangent to the circular field lines. Okay. Normal to the line PQ. So if I am connecting at Z, you can see that if I am connecting to a line between P and Q, this at Z, the magnetic field will be tangent to the circular field. Like it will be normal to the line. It means it will be perpendicular to the line PQ. Okay. So, and at M and N, since it is like these M and N points are diagonally opposite to each other. So the field from two arms, like it effect of two arms will be there, but the field from two arms will actually get cancelled off because M and N are diagonally opposite. So from the statement, if you look at, we have the like four different options. The magnetic field at point P is directed outwards, normal to the plane of the paper, which is not the correct answer, which is wrong. Then the magnetic field at point Q is directed inwards. So that is also wrong. Magnetic field at point P is directed outwards. Point P is directed inwards. Magnetic field at point Q is directed outwards. Magnetic field at point Z is directed normal to the line PQ in the plane of paper. So that is a correct. And now magnetic field is produced outside the hairpin, that is at the points P and N. Okay, so basically magnetic field will be produced, but the effect of magnetic field is being cancelled out. Okay. So the magnetic correct option or the most obvious option is option number C. The magnetic field at point Z is directed normal to the line PQ in the plane of the paper. Okay. So now moving on to our next question. Here we have to calculate, like it is given that a certain water pump rated 500 watt. So I'm writing the power immediately. So the power of the water pump is given as 500 watt. Lift water from ground level to a height of h 10 meters. Okay, so we know the pump is used to lift or increase the height of water. Okay, so at a rate of 240 kilogram per minute. Okay, so right, this is actually the mass flow rate. Mass flow rate is given as mass flow rate means how many amount of mass is flowing in 1 second. Okay, but here it is given as 240 kilogram mass in 1 minute. Okay, per minute. So we have to convert it into seconds. So we have to find out how many kilogram of mass is flowing in 1 second, which is a mass flow rate. So divided by 60, we are going to get it as 4 kilogram per second. Okay, like 240 by 60 is what we do to, because 1 minute equal to 60 seconds. Okay, right. So we are getting 4. So 4 kilogram per second is a mass flow rate denoted by m dot. Okay. So now, ignoring the kinetic energy gained by the water, the efficiency of the water pump. Okay. So how do we calculate efficiency? Efficiency of any machine or efficiency of anything is nothing but it is the output power obtained by input work or input power. Okay. So it is basically output by input. That is the very basic definition of efficiency. Okay. So efficiency, here if we calculate efficiency equal to, it is given by output power, P output by P input. So P input is nothing but the power of the pump, okay, which is actually given as 500. So we have to calculate the output power. So if you calculate the output power for a pump, if it is lifting water to a height h and let the density of water be rho. Okay. So the power here actually, the amount of water, okay, the water is actually being lifted to a height, which means we are actually, the potential energy of the water is being risen, and the potential energy per unit time will be like, we know that what is power? Power is nothing but work done per time, or rate of change of work is power. So here the potential energy of the water is being raised. So that is the work. So in order to raise this water to that potential energy, that is the work done by the pump, or that is the energy that is done by the pump, and we know that energy or work per time will give us power. So the power, output power, is nothing but mgh, where it is not mgh, actually it is m dot dh, because m dot is mass flow rate, because it is the amount of mass flowing in 1 second with respect to time. Okay, so that will be equal to 4 into 9.8 into h will be equal to a height of 10 meters, right? So you are getting it as 392 watt. Now we know that efficiency is nothing but output power 392 watt by input power, which is 500, which is the input power of the motor. So on solving this, you are going to get it as 0.78784, which is 78.4% in terms of percentage. 78.4% is the answer. So answer will be option B. Okay, so now moving on to our next question. An electric kettle consists of two filaments, F1 and F2. Okay, of different resistors R1 and R2 connected in parallel with separate switches with a certain fixed amount of water in the kettle pot to prepare the tea. When only F1 is switched on, it takes 4 minutes to boil the water. When F1 and F2 are switched on simultaneously, it takes 3 minutes to boil the same amount of water. The time taken to boil the same amount of water, only F2 is switched on. So here it is actually, like we know that like F1 and F2 are filaments of different resistances R1 and R2. They are connected in parallel with separate switches. Okay, so if you want to boil the certain amount of water, we have to apply heat, which is provided by the resistance of the filaments. Okay, so obviously we know that when F1 is switched on, it only one filament is switched on, it takes 4 minutes, because only that much amount of heat will be given to the this thing, given to the boiling water, okay, or given to the water. And when both are switched on, the time taken is actually reduced to boil the water because more amount of heat will be generated. We know that H equal to I square RT. So according to resistance, it will actually increase. So what is the time so that it will take the what is the time taken to boil the same amount of water when only F2 is switched on? Okay, so we know that when only F1 is switched on, it takes 4 minute time. Okay, and when F1 plus F2 is switched on, it took a time of 3 minutes. Okay, so we know that power. What is power? So power is nothing but if Q is the amount of heat is a form of energy. It is Q by T is power. Okay, right. So what is the power in the first case when only Q is the amount of heat actually transferred. So let us imagine that first case power is P1 and only one filament is switched on. So that is will be equal to Q by 4. So here the amount of heat will be the same because like it is the same amount of water. So we have to actually have the same amount of heat energy to boil. Okay, so Q by 4. And in the second case, we know that for F2, imagine that the power generated when only F2 is turned on is P2. So from the second case, we know that P1 plus P2 will be equal to Q by 3. So this is the power. Okay. So from this, we can find out the power required for. So I'm writing it here. So P1 is the amount of power Q by 4 with respect to time, energy by time, 4 minutes. Okay. And P1 plus P2, when both the filaments are switched on, it is the amount of energy Q, which is the same by the time 3 minutes. So from this, what is P2? P2, and we can actually subtract. Okay, subtract Q from 1. So I'm getting P2 as Q by 3 minus Q by 4. So that will be equal to, I'm getting P2 as Q by 12, right? So which means this is the power. P2 is the power which is produced when only F2, filament F2 is turned on. Okay. So here the time T2 will be equal to Q by P2, or what is P2? Q by 12. So Q and Q will get cancelled. This will go to the numerator. So time taken will be equal to 12 minutes. Okay. So this is the amount of time which is needed when only the element F2 is being turned on. So the option will be equal to option D, which is 12 minutes. Okay. Okay, so this is basically the question connecting to the heating effect of electric current. Okay, so now moving on to the next question. We have two filament bulbs, B1, which is of 100 watt and 220 volt, and B2, another bulb, which is of 60 watt. Okay, so this bracket is not there actually. So there is a 100 watt and a 60 watt bulb connected in series with a 440 volt supply. So it is connected in series across a 440 volt power supply or supply voltage as shown. When switched on the bulb, so what happens? So actually there is a figure. So I'll just showcase the figure here. Like it's a simple circuit which is given. So like two bulb is there connected in series to each other, and we have a power source of 440 volt. Okay, and we have a switch. So this is a supply. So this is B1 and this is B2. This is 400 watts. So this is the terms, or this is the quantity given. So we have four different options. Out of this, which are the following option is true? When switched on, like if the key is turned on, since it is a series circuit, we know that the amount of current flowing through the series circuit or flowing through both the bulb will be the same. Okay, so which will fuse or which will not fuse is what we have to find out. Okay, so we know that power P equal to power has many formula connected to voltage and current, and also connected to uh, voltage and resistance as well. Okay, so power P according to voltage and resistance, it is V square by R. Okay, so or power P, we know that it is V into I, or power P equal to I square R, or P equal to V square by R. Okay, so this is the power. Okay, so from this, if I have to calculate the filament resistance R, that will be equal to V square by power, right? So now, if I'm going to calculate the filament resistance of the first bulb R1, that will be equal to how much? That will be equal to the V square by P1. So V square is nothing but the voltage of the bulb. Okay, it is not the supply voltage, so it is 220 volt square by the resistance is the power of the first bulb is 100 watts. So what I'm going to get is, on solving this, I'm going to get we know that 22 square is 484. So 484 ohm is what I'm getting. Okay. And now the filament resistance R2 will be nothing but V square by V2. So what is V square? It is the voltage of the bulb, not the supply voltage. 220 square by P2 is the power of the second bulb, which is 60. So, or solving this, the approximate value will be equal to 806 ohm. Okay. So, since it is in series, what is the total resistance? We know that for total resistance in series is nothing but R1 plus R2. So, the total resistance is 484 plus 806, which is approximately the total resistance RT will be equal to 1290 ohm. Okay. So now I need to calculate how much current will be flowing through the circuit. So what is the current flowing through the circuit? I equal to V by R. So V is the supplied voltage 440 and R is the total resistance. Okay, 1290. So a current of approximately 0.34 ampere is flowing through the circuit. Now I can actually find out the voltage across each bulb. Okay, let us this be V1 and this be V2. So voltage across each bulb will be V1 will be equal to I into R1. So I is 0.34 into R1. Resistance of the first one is 484. That is equal to 165 volt. And what is the voltage across? Voltage across the bulb because of the external current and because of the external voltage supply. Okay, so that will be equal to I into R2. So that is 0.34 into, we know that 806 ohm is the resistance. So that is given as 274 volt, which means that the rating of the bulb, okay, the bulb can actually have a voltage rating. The rating of voltage rating of the bulb is nothing but 220 volt. So, which means that is the maximum amount of voltage that the bulb can actually withstand. So, it is very clear that the bulb B2, the amount of voltage flowing is 274, which is greater than 220, which is greater than its rating. So, bulb B2 is going to be over voltage, or bulb B2 is going to fuse because over voltage is given, whereas bulb B1 is actually having only a voltage of 165 volt, which is less than its rated voltage. So it is under voltage, so it will be safe. It will not blow off. Okay. So from this occasion, so from this we can conclude that B2 is going to be B2 fuses, whereas B1 stays safe. Okay. So B1 will fuse, which is wrong. B1 will not fuse, which is correct. B2 will fuse. So option B is the correct answer. Okay. Now moving on to the next question. So this is a question related to the flotation. Related to flotation. So we know that the volume of water spilled out of a completely filled cubic container of side 4 meter, and the container has been now accelerated horizontally with 1.96 meter per second square. So we know that the side, like we have a cubic container of side, let us say call it as side A of 4 meter, and the okay, let's not call it A because acceleration is also there. We will call it as S. Okay, and the acceleration given is 1.96 meter per second square. Okay, so spilling like what, and so it is basically this thing. So we know that we have a cube of water, completely filled cubic container of side 4 meter, and the container is accelerated horizontally 1.96 meter. What happens? Generally, what happens is water will actually move like this, right? So I'll draw a larger figure. Okay, so here I will draw a larger figure. So we have a container which is in the shape of a cube filled with water. So when it is accelerating in the forward direction, the water is going to move in this direction. Okay, so there will be an angle created tan theta. So tan theta is nothing but from this we know that, let us say this is the acceleration and the weight of the water is g. Okay, so tan theta will be equal to acceleration in the x direction by G. Okay, A by G. Okay, so that is the tilt angle, where theta is known as the tilt angle. Okay, so from this, we are actually asked to calculate uh, the volume of the water spilled out of a completely filled cubic container outside. Okay, so volume is what you have to calculate. So volume, how do we calculate volume of the spilled water? Okay, so here on calculating tan theta, we know that the acceleration is 1.96 and g is 9.8. So this will be equal to 0.2. When you calculate this will be equal to 0.2. 0.2 is what you are getting for tan theta. So this height difference, let us say this is okay. So this is L and this is H. So tan theta, we also know that tan theta will be equal to opposite by adjacent. So H by L. So therefore, the height difference in the one side will be equal to L into tan theta. So L is the side of the cube. Okay. So we know that height difference H, I am going to calculate H equal to L into tan theta. So what is L? L is the side of the cube, which is given as 4 meters, right? Right, 4 meters. So 4 into 0.2, which is 0.8 meters is the height difference. So now spill the volume of water. How much volume of water is going to spill? Okay, so that is having a spilled volume is we actually get a shape which is known as a paraboloid. So that volume is equal to half into uh, half b into h. Okay, so half a square into h, or half s square, like the side square into h, which is now on calculating this, I'm going to get it as half g square z power. So half into s is 4, 4 into 4 into 0.8. Okay, so it will be 2, 4, 8, and 6.8 into 8 is 64. 6.4 meter cube of volume, or is the spilled volume. This much amount of volume will be spilled outside. Okay, so the option will be equal to C. Okay, so now moving on to move on to the next question. Two athletes A and B run on a ground on an oval track of length L. Let us say it is having a total length L at 8 meter per second. Okay, so A is running at a speed of 8 meter per second. B is running at a speed of 6 meters per second. Okay, in the same direction, starting from the same initial point. How many laps will the athlete A complete on the track before overtaking athlete B for the first time? Okay. Okay, so like A is actually moving forward and sorry, moving at a higher speed, and B is moving at a lower speed. And how many lap, like the number of round the A will complete on the track before overtaking athlete B for the first time? Okay, so both are starting from the same point, and they are actually running around an oval lap or oval track. Okay, so what is the relative speed between the two? So the relative speed is nothing but a minus b, right? So a minus, because they are in the same direction. So 8 minus 6, which is 2 meter per second, is the relative speed. So the time taken. So what is the time to gain one lap distance L? Okay, so that is on the lap distance. That time will be given by the total distance by the relative speed, which is time t equal to L by 2. Okay. So now we have to find out the distance run by A in this particular time. Okay. So distance run by A in time t. In time t will be equal to distance. We know that distance is nothing but speed into time, right? Speed of A is 8 meter per second into the time, which is given by L by 2. So this will be equal to 4 times L. Okay, so which means that A actually completes 4 laps before overtaking B. So 4 times L means he has to do, like A has to actually complete 4 rounds of the total length, which is L, which means A will complete 4 laps or 4 rounds before overtaking T. So we got it by calculating the time to gain 1 lap distance, which means time to cover or time to just the time taken to overtake B is given by time taken to cover the 1 lap distance, which is the total length of the track for 1 round by the relative velocity V by 2. Okay. Now moving on to the next question. So this is also a question related to flotation. So we have wooden cylinder of density 0.80 kilogram, 0.8 kilogram per meter cube, a plastic ball of density 0.9 kilogram per meter cube, and a rubber cube of density 0.95 kilogram per meter cube, all of equal mass M, float partly immersed in a trough containing water. Okay, so here also there is a figure. So it's nothing. The figure I will just show you. Okay, so we have a, let us say, tank containing water, and we have a piece of wood, cylindrical piece of wood, and then we have a plastic bowl, spherical plastic bowl, and a rubber cube. Okay, and a rubber cube. All these are floating partly immersed in a trough containing water. So out of the following options, which is the correct one? The buoyant force is largest on the wooden cylinder. So what is buoyant force? Buoyant force depends on density of the density of the liquid into G into volume immersed. Okay. The buoyant force is largest on the plastic bowl. Okay. And buoyant force is largest on the rubber cube. The buoyant force is equal on all three. Okay, so we have wood is having a density of 0.8 kilogram, plastic ball 0.9, and a rubber cube of density 0.95. So lower the density, larger submerged volume, which means so if that like all the objects will be partially immersed. Okay, so here we have to find out who has the largest submerged volume. Okay, because this out of the buoyant force, the density which buoyant force depends is the density of water. Okay, so and acceleration due to gravity is constant for all three. So we have to determine who has the largest submerged volume or the maximum amount of volume which is submerged. Okay, so the maximum amount of volume which is submerged will be for wood out of all these options. So since like all hello, yeah. So the largest buoyant force is buoyant force will be largest on the wooden cylinder because it will have the highest volume submerged. Okay, and hence highest buoyant force. Okay. Sorry, the buoyant force actually, if I am having something and like if you are immersing something into it, so higher the density, what happens is it will actually immerse more um, because buoyant force is directly like we also know this from Archimedes principle. What does it states? Like the buoyant force is equal to the weight of the fluid displaced, right? The buoyant force is also equal to the weight of the fluid displaced. So if something is having a lower density, it will actually float with very less portion of water um, below it. Okay, where if something is having very low density, yeah, something is having low density, it will be having the highest submerged volume. So here in this case, the lowest density is for wooden solid cylinder. So the buoyant force will be largest on the wooden cylinder. Okay. So option A will be the correct answer. Okay. So now moving on to the next question. A stone is thrown vertically down into a well. The splash is heard after a time t1. So this is actually a combination of equations of motion and also the sound, chapter sound. Okay. Stone is thrown vertically down into well. So we have like a well of certain height and we are actually throwing the stone vertically downwards. So it's more like a free fall. The stone is thrown vertically up with the same speed from the same point and splash is out heard after a time t2, which means like if I am throwing a stone vertically downward, I can hear the splash of hitting the water at a time t1. So if I am standing at the same position and throwing the stone vertically upwards, so after reaching a certain height, it definitely will go back down. So here the splash is heard after a time t2 because obviously t2 will be greater than t1 because it takes more time, right? So the common initial speed of the stone in both the cases is given by So what is the common initial speed of the stone? Okay, so that is what we have to find out. Okay. The time taken by splash sound to reach the observer. Okay, fine. So how do we calculate this? So we have to calculate the common initial speed by which the stone is being thrown down vertically down, or by which the stone is vertically thrown upwards. Okay. So uh, so if you are looking the time for the downward case, like it is T1. Okay, so we have to calculate. Okay, so here what we have to calculate is we actually have to calculate the difference in splash times. Okay, difference in splash time, if we calculate, we can actually find out from the difference in splash time, we can calculate the amount of velocity with respect to times. Okay, so here the upward time T2, we know that upward time, let us imagine that the time taken for the downward case is T1 and the upward time is T2. Like that is the time at which the splash is heard. Okay. So, hmm, so if I'm considering the downward time T1, that is actually a combination of the upward time. In the second case, object is being thrown upward initially and then the object is coming down. So the downward time is nothing but the upward time plus this T1, right? Okay, so we can actually calculate in that manner, okay? Because if the initial speed is same, it will be the upward time, like T upward plus the extra time that is taken, okay? So T upward time is if it is moving with the moving with a constant speed. If I'm throwing something with a constant speed U, so the upward time will be given as Tu will be equal to U by G, okay? The upward time, let us say it is Tu will be given as U upon G, okay, because it is moving with the velocity U, and since it is against gravity, acceleration due to gravity, the time will be taken as U by G, okay. And now the downward time, let us say if H is the height at which the water is there from the top portion of the well, okay. So the downward time will be equal to, so the downward time from equations of motion will be equal to root of 2h by g plus u by g the whole square. Okay, so this is the downward time taken. And so from this we have to calculate. Okay, so we can actually calculate uh, T1 is nothing but the downward time and the upward time. So if you are actually calculating the difference in time or the difference in splash time, that is the extra upward time. So difference in splash time is uh, T2 minus T1. So this is the extra upward time which is given by U by G. Okay, so from this, the extra upward time Tu is U by G, and that is equal to the difference in splash time. Okay, difference in the splash time. So this is a very basic concept. So that is will be equal to T2 minus T1. So if you are able to find out the upward time in the sense, one condition is that it is directly falling vertically downward, taking a time t1. The other condition, it is going upward with the velocity u, and after that it is falling down, and the time taken is t2. So we have to calculate this extra difference in time. So that will be equal to the difference in the splash time, which is t2 minus t1. So the extra difference in time is nothing but if it is projected at a velocity u, and from the equation of motion, like we know that v equal to u plus at, right? So if it is being projected upward with an initial velocity u, the final velocity not reaching the top will be equal to 0. So we know that u equal to at, because since it is from this v will be 0. So u minus u will be equal to minus gt, since it is moving upwards. So this is why we are getting the upward time t as u by g. So this u by g, the extra upward time, is the difference in the splash time, which is t2 minus t1. So from this, we will be calculating the initial velocity, upward velocity, which is equal to g into t2 minus t1. Okay, so this is a basic concept of sound and equations of motion. Okay, so the only difference, so what we have to focus here on the question is that one is being thrown upward. So how much time the body will travel in the upward direction is the extra time. Okay. Other than that, after reaching this maximum height, it is going to travel. It takes a time T2. But T2 is nothing but this upward time plus T1. Okay. So this upward time is the difference between the time of splashes, which is T2 minus T1. Okay, so from there you are getting the constant velocity as u equal to g into T2 minus T1. So option A is the correct answer. Okay, so now moving on to our 12th question. So this is a condition, this is a case for a mirror. Okay, a lens actually. So a beam of light is incident parallel to principal axis of a convex lens. We have a convex lens of focal length f equal to 20 centimeter. Plane mirror PQ inclined at 60° with the principal axis is placed at a distance D behind the lens so as to form a real image. Okay. Eye of the distant object at distance D dash from the optical center as shown in the figure. So in the figure is, I will draw the figure actually. So I have a convex lens of O and a mirror is placed at an angle. Let this be the mirror AQ. Okay, so mirror is placed at an angle of 60°. So here beam of light is incident parallel to the principal axis. So that this be the principal axis. So beam of light is coming parallel to the principal axis. So when it is coming parallel to the principal axis, we know that it will be converging at the focus of the convex lens, right? So this is the focus. Okay, this is the F. So which means ongoing the light ray is actually hitting the mirror and the reflected light ray is going to be formed like this, and this is the figure given to you. Okay, and this one also formed here. So you are getting an image here. I is the image. Okay, so if the if the optical center and the pole of the mirror is at a distance d apart, um, placed at a distance d behind the lens so as to form a real image I of the distant object at a distance d dash from the optical center of the lens, the value of d dash. So if this is the image and let us say this distance from the optical center, this much distance is d dash. So what is this distance? What is this distance d dash is what we have been asked. Okay. So this is a mirror problem, but this is also a geometry related problem. Okay. So convex lens and plane mirror is at an angle of 60°. So we know that the convex lens have a focal length of f equal to 20 centimeter, and we know parallel light rays are converging at f. So in between there is the plane mirror, which is actually redirecting the converging light rays in the upward direction, right? So the image distance d from the lens. Okay, so here also we are going to get the real image because of the convex lens d, and of this real image we are actually getting an we are getting a virtual image, and of this we are getting a real image at f. Okay, so so using geometry we have to calculate the distance between the uh, mirror and the lens. Okay, so uh, we have to, first of all, we have to use lens formula in order to calculate. We know the object distance is not given, but based on the lens formula, we know what lens formula is, like 1 by v minus 1 by u equal to 1 by f. Okay, so from this we have to calculate, we can actually calculate the object distance, and the object distance d will be equal to so if you look at the geometry of this mirror, uh, like this is the mirror, and this is at an angle of 60°. The plane mirror peak is inclined at a 60° with the principal axis. So this angle is 60°. Okay, so which means that if the light ray is parallel and it was parallel and is going to convert. So here this is the incident light ray. So this is going to make an angle of 60° as well. Okay, this is the normal. So this will also make an angle of 60°. So using this, we can actually calculate the distance of the image I dash as d equal to 10 centimeters. Okay. So the correct option will be 10 centimeter. Option B is the value of the image that is being formed. Okay. So moving on to the next question. Now we have two cylindrical vessels are there, V1 and V2, which are placed on the same horizontal level. Each vessel contains the same liquid of density rho. Like one horizontal level is there. We have two cylindrical vessels, V1 and V2, placed on the same horizontal. Each vessel contains the same liquid of density rho. Like the liquid is the same, and initially the vessels are not connected using a valve, not connected. Height of the liquid in vessel V1 is H1. So one is having an height H1, and that in vessel V2 is H2. Let us say this is H2. The diameter of vessel V1 and V2 are 2D and D respectively. Okay, so one is a larger diameter. So this is actually a larger diameter vessel, which is 2 times D. This is a smaller diameter vessel, which is D. When vessels are interconnected, valve opened at the bottom. So here also we have a figure. So it is more like a hydraulic pump. Okay. So the figure is this one. Like we have a larger cylinder and connected by a valve, and this is a smaller cylinder. So here the water level is, this is the water level, and here the initial water level before being connected. Okay, before opening the valve was, this is the valve. Before opening the valve was H2 and H1. Okay. Now, when vessels are interconnected and the valve is open at the bottom, the height h of the liquid in each vessel. So, what happens is generally we know that water is going to flow from the higher level to the lower level. Okay, so it will flow. The flow will continue till the water level on both the surfaces reaches the same height. So, after opening, let us assume that the water level is h for both the conditions. So, here, what is the height h of the liquid in each vessel, neglecting the volume of the liquid in the connecting tube? Okay, because connecting tube is considered to be very small here. So we are actually neglecting the volume of the connecting tube here. So we have to find out the final height h. We have to find out the final height h of the liquid in the two vessels. Okay. So how do we solve that? Okay, so we are having two different two different bodies having height h1 and height h2. So here we have to find out the top, like final height h. So we will write all the data which is given. Height of the water level is h1 and the diameter is 2d, and height of the water level in the second tube is h2 and the diameter is d. Okay, so we know that what is the ratio, what is area? Area is nothing but area of circular area pi by 4 d square. Okay, so we know that area is proportional to d square. So when taking the ratios of area a1 is to a2, what will it be? It will be equal to d1 square is to d2 square. So what is d1? It is 2 times d, the whole square, is to d square, right? So I'm getting the ratios of area as a1 is to a2 as 2, sorry, 4d square is to d square, which is d square and d square will get cancelled. So 4 is to 1 is the ratios of areas. Okay. Now the final height at which water is there is h. Okay. The final height is h. What is the total volume? Okay, so the total volume, uh, we know that area, ratios of area, like should be equal. Okay, so total volume remains the same. Like we are not considering, there is no loss of volume, right? Initial volume will be equal to the total volume. So if area is, let us say 4 is to 1, we know volume is nothing but area into height, right? So in this particular case, initial volume was 4h1 plus h2. That should be equal to the final volume. Final volume also, volume remains the same because water is not spilling out. So it will be equal to 4h plus h, because the height of the final condition may the height of the both the containers are actually equal. So if h is the height and if this is having an area of, let us say 4 meters square, this is having an area of 1 meter square. So obviously 4h plus this h will be the total volume. So initially it was having a height of h1 and h2. So we are getting 5h is equal to 4h1 plus h2. Then what is h with respect to h1 and h2? It is nothing but 4h1 plus h2 by 5. So this is the answer. Okay. So how do we reach to this answer is we know that the water is not spilling, and this statement is given. The volume of the liquid in the connecting tube is neglected, which means initial volume will be equal to the final volume. So that is how we actually got this height h, which is 4h1 plus h2 upon 5. So option B will be your correct answer. So now moving on to the next question. There is it is based on collision. Okay, so 80 kilogram man skating with a speed of 10 meter per second on a smooth horizontal surface. So there is a smooth horizontal surface and mass is there. Man which is having a mass of 80 kilogram, and it is traveling with a speed of 10 meter per second, collides with a 20 kilogram skater. Let us say there is another 20 kilogram skater, and the 20 kilogram skater was at rest. Okay. So there was no velocity. As a result, the two cling to each other. Like to cling to each other means to stick to each other. What percentage of initial kinetic energy of skaters is lost during collision? So we know that we have to find out the loss of percentage in loss of kinetic energy is what we have to calculate. Okay. Then friction is not considered here. Okay. So how do we calculate? We have to find out the initial kinetic energy of the system and the final kinetic energy of the system. Then we have to find out how much percentage is the final kinetic energy compared to the initial kinetic energy. So we know that what is initial momentum here? Initial momentum is mass times m1 v1. So that is 80 kilogram into 10, which is initial momentum is nothing but 800 kilogram meter per second. Okay. And initial momentum for the initial momentum for the second skater is nothing but 0 because it was at rest. Okay. So we know that what is the final velocity? Like after that, this is said that they two cling to each other, means they two stick to each other. Okay. So uh, on sticking to each other, like we know that total momentum should be conserved here. So initial momentum before collision should be equal to should be equal to the momentum after collision. So after collision, we know that the mass is nothing but so let us say I'm taking this as in P2, which is the momentum after collision. That will be equal to m1 plus m2 into final velocity v. So what is final velocity? It is nothing but P2 by m1 plus m2. So what is P2? It is nothing but the initial momentum because momentum should be conserved in the collision. So that will be equal to 800 by the total mass will be 80 plus 20, which is 100. So 800 by 100, you are getting 8 meters per second. Okay, so 8 meter per second is the final velocity when they stick together. Okay, so this is the final velocity. Okay, and so now I'm going to calculate the initial kinetic energy of the system. So let us say initial kinetic energy is half mv square. So since second skater is not moving, it doesn't have any kinetic energy. So it is because of the first skater that the system has a kinetic energy. So that is half into mass of the first skater into velocity of the first skater. It is 10 square. So this will be equal to 40. This is 100. So 4000 joule is the initial kinetic energy. Now calculating the final kinetic energy. Final kinetic energy is because of the combined velocity of these two, or the final velocity of the two masses, two skaters. Here the mass will be the combined mass, half m1 plus m2 into the final velocity square v square. Okay, so that will be half into 100 into final velocity is 8 meters per second. Okay, 8 square 64. So this will be 50 into 64. You are going to get it as 3200 joules. Okay, so now we are going to find out the percentage loss in the kinetic energy. So how do we calculate that? It is nothing but uh, difference in kinetic energy, delta kinetic energy by initial kinetic energy. Initial kinetic energy into 100. So the difference is 800 joules. 800 joule by 4000 into 100. So you are getting, and here also 1 0 will go. So this is 2. So you are getting as 20%. So 20% reduction is happening in the kinetic energy because of the collision. So your answer will be option C, which is 20%. Okay. So now moving on to our next question. So we have, this is a question of overlapping images for lenses. Okay, so we have two vertical object pins are located on the principal axis of a thin lens at a distance of x1. Like we have two objects at a separate distance at different distances located at 9 centimeter and 18 centimeter from the lens on the two side of the lens. Okay, so image of the lens, image of the two pins found by the lens are at the same position. So images are being overlapped. So what is the focal length and nature of the lens? Okay, so we have to find out the focal length and the uh, nature of the lens, like what kind of lens it is, whether it is a concave or a convex lens. So how do we find out whether it is a concave or convex is by finding out focal length if it is positive and if it is negative. Okay, so we know that the distance, object distance or the pin is at a distance of x1 equal to 9 centimeter and x2 equal to 18 centimeter, right? So uh, according to sign convention, we actually take this is the object distance. So object distance is given by u. So according to sign convention, u1 is -9 and u2 is -18 because object distance is always considered negative. Okay. So now we know that the conjugate distances for the lens in order to satisfy the conditions. So the conjugate distance satisfy the condition u1 into u2 equal to f square. Okay, conjugate distance. If the images are overlapping, the conjugate distances satisfy the condition u1 into u2 equal to f square. So from this, what is f? F is nothing but root of u1 u2. So this is the condition. So we can actually find out the focal length from that. So f is nothing but the root of -9. We only need to take the magnitude 9 into 8. So 9 times 18, which is root of 162. So when you are calculating the root of 162, it is approximately equal to 12.7 centimeter. Or maybe we can say like, just for convenience, let us take it as 12 centimeter or even 13 centimeter is fine. Okay. So, or like 13 centimeters in nearest approximation. So here we are actually getting a focal length f approximately equal to 13 centimeters. So we have to find out, yeah. So here, if in the option, the nearest option is 12 centimeters. So it's better to take the approximation of as 12 centimeters. So focal length is approximately equal to 12 centimeter. And since the focal length, the sign for the focal length is actually positive, or even if you are using sign here, -9 and -18, you are going to get the focal length as positive. So since distances are real and images forms on the opposite side, so the object distances are real, okay, and image is actually formed on the opposite side of the lens, which means you are actually getting a convex lens. So for a convex lens, because uh, for a convex lens, the if object is here, the image is being found on this side. Okay, so this is a convex lens. So this from this we can understand that this lens is a convex lens of focal length 12 centimeters. Okay, so this is the condition. So what will be the correct option? So this will be 12 centimeter and the lens will be convex in nature. So that is the case. Okay, so now moving on to the last question. So we have, this is relative motion and relative velocity. Okay, question related to that. So a steamboat goes across a lake up to a distance of 1,200 meters and comes back. There is a uniform wind blowing with a velocity v. There will be a space here. Okay, so as to help the onward journey and to impede the journey back. So the wind actually helps when it is moving forward, and wind actually impedes, means wind actually resists the journey of the boat while coming back. If the uniform speed of the launch of the boat is 5 meters per second, uh, and the total time taken by the boat in going and coming back is 500 seconds, velocity of the wind blown. So this is a classical case of relative velocity problems. Okay, so here what are the data given? So we have a boat. Okay, so let boat speed, like in the still water. So uniform speed of launch means this is the speed of water, sorry, speed of the boat in still water. Okay, in still water, that equal to 5 meter per second. Okay, so still water speed, let us say that is equal to 5 meter per second. So speed of boat in the sense is 5 meters per second. Okay. On so when the boat is going downstream, and let us take the wind speed. Okay, speed of the wind as let us consider. We have to calculate speed of wind. So let us take speed of wind as v here. So on going downstream means sorry, on going downstream means the wind is actually helping it. Okay, so this is downstream. So on going downstream, the velocity v1, like the velocity is because of the speed of the boat or velocity of boat plus the velocity of wind. Coming back, the wind is actually against the motion. So wind is impeding it means if the speed at which the boat is coming back is v2, then we know that it is impeding the motion, which is 5 minus v. Okay, so on going downstream, it is v1, it is 5 plus v, and on going upstream, if I'm taking the velocity, relative velocity as v2, that is equal to 5 minus v. Okay. So now the total distance, like it is going up and down 1200 meters. So the total distance will be 2400 meter. Okay. So total distance is up and down, total distance is 2400 meters. And the total time up and down total time is given. Okay, that is why we took the total distance 2400. So that is 500 seconds. So 500 seconds is the total time. So we know that like if T1 is the time taken for the upstream and T2 is for the downstream. So T1 plus T2 will give the total time T, right? So what is T1? Speed, time is nothing but distance upon speed, right? So here on substituting this, we are going to get as one way distance is 1200 and one way speed is 5 plus v plus downstream distance is also 1200 and 5 minus v. That is equal to total time 500 seconds. So we have to solve this equation in order to find the v. So we will be actually getting a quadratic equation. So here I am taking how do you solve, like we can actually take the LCM and yeah. So on solving this as LCM, we are actually going to get it as 25 minus v square will be equal to 24, or v square will be equal to 1. So what is v? V will be equal to 1 meter per second. Okay, so on solving this equation number 3, let us say I'm taking this as equation number 1. Okay, so on solving this, we are actually going to find out the value for v. So this is the solution. On solving this, we will be getting, like on taking LCM, we will be getting 12,000 by 25 minus v square is equal to 500. So rearranging this, we are actually getting 25 minus v square equal to 24. So v square will be equal to 1 meter per second. Okay. So out of the option, if you look into the option, the option C is the correct answer. So 1 meter per second is the velocity of the wind blown in this particular question. Okay, so this is the discussion. This is the answer and solution for all the questions. So hope you have understood the questions and understood the solutions very well. So see you again. All the best for your future. Thank you.